Okay. Hey, it's time. It's time. Cramer's rule. Can you guys see this right here? It's sick. Okay. So this is gnarly cool right here. So I'm just gonna show you guys the kind of the procedure for this, and I don't know. I love the Cramer's rule. Okay, so we have 4, -2, and 3 and -5. And what we're going to do is we're going to find a determinant of this. And I got those from the coefficients from that part of the equation. I'm not making an augmented matrix. I'm just pulling out the coefficients from the variables and making my matrix from that and finding the determinant of it. So the determinant of this is, 4 times -5 is -20. And then I'm going to subtract 3 times -2, which is -6. And that's going to give me positive... -14, and that's your determinant for just the coefficients. Now, the goal here is to find the x and to find the y. Find the x values and find the y values. You guys are used to doing this by solving using substitution or elimination, or even an augmented matrix, which is what we learned how to do last week. Okay, check this out. This is so cool. So, if you're trying to find the x, what you can do is you can take your your determinant of just the coefficients, and then on the top, you take you make a new matrix. You kind of just copy this one, but you replace the x coefficients with these guys. So watch this. You go -2, -5, because those are my y's. The x is right here. I'm going to replace with these guys. So it looks like this. 10 and 11. This equals...
Wait, is it a matrix? Or
we're going to find a determinant of it. Okay. That's why I have the straight lines. So I have -14 right there. On the top, I have 10 times -5, which is -50, minus -2 times 11, which is -22. So that's adding 22. -50 plus 22 is -28. And that is going to equal, see, -28 divided by -14.
2.
That's positive 2. That is your x. That's it. Done. Now, for the sake of practicing, I'm going to use Cramer's rule to find the y as well. Now, you could just take that x and plug it in, just like you did before when you were solving systems. But I'm gonna find the y using Cramer's rule also, just because I think it's good for you guys to see it right now. Okay, so I put the -14 on the bottom. On the top, I'm going to put, okay, this time I keep the x's, so 4 and 3. I got that from here, 4 and 3. And the y's I'm going to replace with the 10 and the 11 because that's what I'm looking for. So on the bottom, I still have -14. On the top, I get 44 minus 30. 44 minus 30 is 14. So I have 14 divided by -14, which is -1. So my answer for this problem is 2, -1.
And is it going to always be?
Now let's look at a 3x3. Don't say, oh, you guys are going to love this. Check this out. No, trust me, you're going to love this. If you didn't like the elimination and substitution with solving a 3x3, you're going to heart this one. You're going to heart... With the heart, with the hands and that little sign and everything, you're gonna heart Cramer's rule. I want to see a shirt with a heart and Cramer's rule next week when I come to class. Okay. All right. Okay. So our determinant for this one: -1, 2, -3, 2, 0, 1, 3, -4, 4. We're gonna find the determinant of this one. Now this is not as pleasant because the determinant of a 3x3 takes a little bit more time, but one of these rows actually doesn't look that bad, this row right here, because it has a 0 in it, and 2 and 1, those are pretty small numbers. Does everybody understand how I got all these numbers? I was looking at the coefficients right here. There's a 0 right here because there's no y, so I put the 0 there in the middle. So let's do it. So this equals, here we go. We're going to use the 2, don't need the 0, and the 1. Okay, so we're going with the middle row right here. Okay, with me? Okay, so since we're going with the middle row, let's see, we'll go 2 right there, and we send out our lasers, and we have problem here. We got to go 2, -3, -4, and 4. In fact, since we're using the middle row, let's just cross it out because we're not going to use that at all here. That's going to be crossed out with lasers all the time. And for 2, the first column gets crossed out, so we have the 2, -3, -4, and 4. And we have to find the determinant of that. Can you guys tell me if the sign is going to change?
Yes.
For this one right here?
Yes.
The sign is going to change. Okay, so let's put a negative right there in front for now. And we'll go negative, and then let's do our business. 2 times 4 is 8, and then -3 times -4 is +12. So I have -12. 8 minus 12 is going to be -4. And -4 equals 4. And so I throw a 4 right here, and now I only have one more to find. I have this 1 right here. So I send out lasers, that column will be crossed out, the row will be crossed out. And my new little matrix to find the minor is -1, 2, 3, and -4. And now for the cofactor, for this spot right here, is that going to be, is it going to change the sign or is it going to keep the sign? It's going to change the sign because this would be positive, this would be negative, that would be positive, and this would be negative right here. And so I'm going to throw a negative right here in front of my determinant to remind myself it changes. Writing out all your steps, all your work is so incredibly important here because that's how you're going to make mistakes, is trying to do everything in your head. -1 and -4 is +4. I know because I keep making them myself. I'm trying to come up with problems for you guys, and I'm doing them by myself, and I'm just like, I'm just going to do it in my head, and I keep making mistakes until I write everything out. It's really annoying. 3 times 2 is 6. Maybe it's because I'm not a calculator. 4 minus 6 is -2, so I have -2, which is a +2, and I throw the 2 up here. Now you guys can see, man, look at these pretty nice numbers. Oh, it's so pretty. Okay, we have an 8 right here, 2 right there, it's a 10. So our determinant is a 10 for the 3x3 matrix. Now we can find our x, our y, and our z. Oh, snap. Let's find our x. X equals the 10 on the bottom, and then on the top, oh, this is kind of gnarly. We have, okay, now we're looking for the x's. So we're cutting out this column right here, because that's the x column. So let's write the other ones that we already know that should be there. We have 2, -3, 0, 1, -4, and 4. The other column, the x column, is going to be replaced by these numbers right here, the ones that the equations equal. So we have 1, 0, and 2.
So whatever variable you're trying to find, you plug in.
Right. Whatever variable you're trying to find, you plug in the constants for that. What the equations equal. Okay? So now, you guys should be getting excited right now because you see a row with 2 zeros in it.
Oh, now I do.
Now, to find the determinant of this whole thing right here, we're just going to use this row right here. Has 2 zeros. That's a beautiful thing. That means we don't have to add anything like we had to up here. We just find one of the cofactors and multiply it times 1. So we have 10 on the bottom, 1 times the cofactor for this dude. So send out my lasers. I have 1, 2, 1, 2, 2, and -4. Now, I could probably do this in my head, but I'm going to write it out just to make sure I don't make any mistakes. Now, since this is a cofactor,
0.
is it going to change the sign? Or is the sign going to stay the same?
It's going to be negative. It's going to change.
It's going to change the sign. So, because of where it's at, when we're thinking about our sign matrix, we have negative right there. So it's going to be 1 times -4, which is -4, and we're going to subtract. Throw our negative right there in front. And subtract this. 2 times 2, which is 4. -4 subtract 4. Oh, yeah, see? I would have made that same mistake that you just made. Yeah. -8, then we have -8, and so we put a -8 right here. No, +8, because negative is positive. So we have 8 over 10, which simplifies to 4 over 5, and that, my students, is our x. It's the start of our 3 coordinate points. 4, 5. Yeah, you guys like that, don't you? Yeah, you do. Yeah, you do. Okay, now we can do this for each variable. We can find the y this way, we can find the z this way, and then you'll be done. Now, to keep this video simple and short, I'm not going to do the y and the z, but after you do it on your own, you'll find that these are your answers. Yes, look, they're so ugly. But doing the determinants isn't that bad, and it comes out to be nice and pretty. Pretty answers.